because you have 2 hydrogen. The molar mass of hydrogen is 1. So you multiply 1 times 2, which will give you 2. And then you have oxygen, which is 16.
Where to find group me private messages? Oh, my bad, my bad.
Okay, so oxygen is 16. So you add the 16 plus the 2, which will give you 18. That's why you have 18 grams of mole, because that is 1 water. So you have your 30.6 of grams over your 1 water, which is 18, which gives you the 1.70 moles of H2O. Does everybody understand that?
Yeah.
Hold on just a second. Okay, sorry you guys. What was I? Okay, so now to find the anhydrous salt, which is the salt you have basically gotten after heated. You have 69.4 grams, and where that come from is, so you have 100 grams, and you're going to subtract the water mass, which is your 30.6. 100.
I have a question.
Yes, I'm listening.
When we're like doing these type of problems and you get one of the percentages, do you always kind of like not assume, but do you always like go to it being 100 grams so you can find the other salt percentage?
Yes, it'll always be 100 grams.
Okay, so that way you could like convert
It
it.
will always be 100 grams unless it tell you otherwise.
All
Like
right.
it specifically says over 100 grams, but you will always do it out of 100 grams.
Okay.
Yes, no problem. So 100 minus 30.6 will give you the 69.4. Yes, 69.4 grams. And so again, they gave us our whole molar mass of our anhydrous salt, which is the 245. So you would do the 69.4 over the 245, which would give you the 0.283 moles of your anhydrous salt. Okay, so from this ratio, then we can calculate the water of crystallization. And that way you have everything because you just calculated your moles of water and you just calculated your moles of anhydrous salt. So you would put them over each other, and it would give you the total answer of 6, which is your 6, meaning you have 6 waters. Basically, that's what that means, 6 waters. So of hydration, basically 6 waters of hydration. So then you can calculate the entire total mass of your formula, which would now be anhydrous salt times your 6 waters, because we just calculated 6 waters. So that'd be your 245 molar mass times your 6 waters, and then times 18. 18 again come from your water, your 1 water, which would give you a total of 353 AMU. And that's your total mass for the anhydrous salt times your 6 waters. Did everybody understand that, or did I lose anybody?
I get it.
It makes sense. Thank you.
Okay. So let's skip down to number 4.
Number 4.
Yeah, let's skip down to number 4.
Okay.
Hold on, give me a second to read it. Okay, can anybody tell me how they would start this?
Yeah. For 4A, so you're trying to find the percentage by mass of water, right?
Right.
Okay. So wait, I'm gonna have to look back up. I kind of forgot. Okay, so yeah, all right. So you subtract the total mass, the 3.914, minus 2.914, the mass without the water. So you go from with water to without, and that gives you
Right.
1 gram flat. And so 1.000 grams of water. So 1 gram of water. And then the percentage you're going to take that mass, the 1 grams, and you divide it by the total, and then that gives you the percent, and then you multiply by 100, and I give you the percent.
Right. So for everyone that's listening, you get 1 gram over the total, which is what?
3.914. Wow.
3.914 grams times 100, and that gives you what? For those who have calculators.
25.549.
So 1 divided by 3. Right. Gives you 25.549, right? Because we have 3 sig figs.
Yes. So yes. Same thing.
Or you could round it and say I'll take 26%.
I have a question. It was
I'm
1
listening.
gram over what? What was the value you had under it? Because I think I had a different.
Your total would be 3.914 because that's the total mass without being heated.
Oh, okay. I had 2.914. All right.
I have a question. I thought it would have been mass of water over mass of the hydrate.
Hold on just a second. To those who are in the chat, you have till midnight to turn it in. Okay, so who just spoke to me
Me.
about the mass of the water?
Oh.
Hi. Okay, so tell me how you would do it.
Well, I thought, you do subtract it and then you get that 1 gram as the mass of water. But then I was looking up ahead at the formula and I thought it was mass of water over mass of the hydrate. So I would divide 1 by 2.914. And then I got, and then I multiplied it by 100. And then I got 34.317.
So you divided it by what number?
2.914. I thought you divided by the hydrate. Oh, I'm sorry.
Right, that's the anhydrous. So that means the hydrate would be the
Oh, I read the problem
3.914
wrong. Sorry.
because yeah, you got it. Okay. Okay, so is everybody on the same page? So you do 1 divided by 3.914, which is your total hydrate, because your anhydrous would be the 2.914, and then you would get a total of rounded 26%. Is everybody okay with that?
Sorry, can you like repeat that, please?
Okay, so initially in 4A, what you're gonna do is you're gonna subtract the 3.914 grams, which is your hydrate, right? Minus the 2.914 grams, which is your anhydrous, because you heated the reaction, and you're gonna get 1 gram. So you're gonna do 1 gram over the initial amount, which is your 3.914, which is your hydrate, and you should multiply that times 100, and you should get roughly 26%.
Okay, yeah, but you said 3 sig figs, so that's so we're doing 25.5.
Yeah, I said I would either take 25.5, or you could round it to 26%.
All right.
Okay, so now we're on 4B, right?
Yeah.
All right, can anybody help me with this one? Anybody know how to do this one?
Where's my paper?
So you have grams of water were
Oh,
removed, hydrated salt.
yeah, we just did that, right? Isn't that the it's
Wouldn't it
one.
be 1?
Right, because you would subtract the final amount of the initial, right?
Yeah.
All right, cool. All right, 4C.
Wait, can you explain 4B again?
Okay, so all right, so initially you have 3.914 grams of the hydrated salt, right, which is your calcium sulfate, right? And it was heated, which means that it lost water, right? And so they said your final result was 2.914 grams. So you would subtract your 3.914 minus your 2.914 grams, which would give you a total of 1 gram.
Oh, okay. Thank you.
Oh.
Can everybody hear me?
There we go.
Hear you now.
Yeah,
Oh, I'm
you're
sorry.
We can hear you now. We can hear you
Sorry,
now.
I was speaking on mute. Sorry. Okay, so we're on 4C. So can someone explain to me, how do we figure out the mole? So from 4B, we figured out the grams. So how will we figure out the moles of water?
okay. All right. Moles. Isn't that you'll do grams divided by what's that called? Molecular mass, I believe.
So
So
Uh-huh.
You,
I'm listening.
so that's the unit because they said that like it was at the top. And so what you'll do is you'll do 1 gram of water divided by the molecular what's it called? The molar mass, sorry. And that'll be so it'll be 1 divided by 18. And then that should give you the moles, right?
And that gives you, does everybody agree with that?
Yes.
And that'll give you what?
I got 0.06.
Can you
Yeah.
say it one more time for me?
Okay, so yeah, you'll do 1 gram of water because that's you calculated the grams of the water in 4B. So you would take that 1 gram of water and you would divide it by the 18 grams per mole because water in general is 18, right? So that gives you 1 divided by 18.
It's 0.055 moles. That's the ratio because the grams would cancel out. You just have moles left.
Right, so you'll do
Wait, would it be one significant figure?
yeah, but I mean in this case you can just do 0.01. I meant 0.1. That's what I meant.
What did y'all say the answer was?
For C is 1 divided by 18, which is 0.1 if you round it. Everybody clear on that
Whoa,
one?
whoa. Wait a minute.
Oh, so it's not point
Wait,
zero.
you're right. Never mind. That's right.
Oh, wait. So do you want us to round it, or can we just keep it at 0.06?
Oh, you can keep it at 0.06 if you want. I'll take 0.06 or 0.1 as a whole.
Okay.
I have a question about the sig figs.
Yes.
How do you know how many you're using for the answer?
Well, in this particular case, you would do 1 sig fig, so to be 0.1. I'm not too big on sig figs as far as the answers, but like I said, because somebody said 0.06, which is also correct, but it can also be 0.1. It just depends on how you do your sig figs. But in this case, it'd be 1 fig.
I was saying, why is it one sig fig?
I'm sorry, it'll be 2 sig figs because 18 has 2 sig figs.
Okay, that's why. Okay. Thank you.
Is everybody clear on that one?
Yes, it's clear.
No,
Yeah.
wait a minute. Okay. I understand it's 1 sig fig, but like, why did you round up? Because if it's 1 sig fig, can you just do 0.06?
Well, I just said that it's 2 sig figs because you have 18, right?
Yeah, but you also have 1.
Let me make sure I'm telling you guys right because I think it's 0.06. Yeah, okay. It's 0.06. Hello?
Yes. Okay. All right. Thank you.
Can you repeat that?
So for 4C it's gonna be 0.06. Yeah, 0.06 because the 0 is significant and I give you 2 sig figs. Okay, everybody's on the same page?
Yes, thank you.
Yes. Thank you.
Okay, so now we're on 4D. So calculate the number of moles of the anhydrous salt. So how we go by that? It's the anhydrous, not the hydrate, right?
Yeah. It's kind of the same process. So you would get the it's gonna be grams divided by molecular mass. So in this case, you're gonna do 2.914, and you're gonna divide that by whatever the molar mass is, or molecular mass is, or molar. I don't remember. I think it's molar mass.
It's molar mass. So how do we find the mass of calcium sulfate?
You're gonna have to calculate it because they don't give it to you. So you have to look on the periodic table and figure it out.
Does everybody know how to do that?
Yes.
We go over.
Okay,
Yes.
so can somebody give me the total of calcium sulfate?
Please.
$159.62.
That was fast.
Did everybody get the same thing?
What did
May
you
you
say it was?
Yeah, may you please repeat that?
I got 159.62.
I'm
I
calculating.
trust it.
Hold on.
Appreciate you, Daniel.
Hey, no
I got
problem.
136.15.
Whoa. Wait, what?
For calcium sulfate's molecular mass, it's 136.15 grams per mole.
Uh-oh.
Okay, I'm gonna calculate. Hold on.
And y'all said the way y'all calculating it is looking at the periodic table.
Oh,
Yeah,
he's right.
look-
It's 136.14 grams per mole. 136.
136.14.
Yeah. That's what I
All
had to
right.
say.
All right, so let's break it down for those who need it. Okay, so if you look at the periodic table, you see calcium. Calcium has a molar mass of 40.078, right? And you have sulfate, which is SO4. So your sulfur is 32.06, right? And then your oxygen is 15.999. And you have 4 of those. So you would multiply the 15.999 times 4. So I get 40.078 plus 32.06 plus plus 63.996, and I get 40 points.
Excuse me, Morgan.
136.134 grams per mole. Yes, I'm listening.
Hi, there's someone waiting in the waiting room.
Okay, 1 second. Got him. Thank you.
Why'd you use it?
Hello. Okay. All right. So you guys, I got what he mentioned, 136.15 grams per mole. Did everybody get that?
I thought it was 0.14.
136.
Yeah, me too. Do we round?
Hold on.
Yeah, I have 0.14.
0.1.
0.1406.
Point 0.14. Maybe I miscalculated something. Hold on.
You did 13.06. I think you should have did, 13. You did 32.06. I think you should have did 32.07. Because on this periodic table because the periodic table in the book says 32.065.
Oh, okay. Yeah, so you're gonna get a different variation because my periodic table says 32.06. So it gave me an answer of 136.134 grams per mole. So yeah, maybe a slight variation. But if I do it for point, you said 0.07?
Yeah.
Yeah,
Try.
let me see, 32. If I do it with 0.07, I get 136.144 grams per mole. Is everybody okay?
Yeah.
Excuse me. Yeah.
Okay. So for, what is the last, is it the last one? Are we on E? Yeah. Okay. So for E, calculate the mole ratio of water to calcium sulfate.
Wait, I'm sorry. I'm sorry, Morgan.
Yeah, I'm listening.
So what did y'all end up getting for 4D?
For 40, I got 136.144 grams per mole.
Oh, so it just stopped when we calculated the molar mass? You didn't have to do nothing else?
Oh, I'm sorry, we ain't finished. Okay, for the calculated number of
Did
moles.
we finish it?
No, we did not. I'm so sorry. Calculate the number
No,
of
you're
moles
good.
of the anhydrous salt attained. Okay, yeah. So how do we find the moles, you guys, if we already have the molar mass?
You divide the grams versus the molar mass.
Can you repeat what the molar mass was?
The molar mass is 136.144 grams per mole.
Would we do 2.914 grams divided by like 136.14 grams per mole?
Mm-hmm.
And then get 0.018 moles?
Right.
I think that's right.
Oh. Wait, what did you get for D, Akil?
0.018 moles.
Whoa.
What did you get?
I got 0.0214.
I'll take a picture and send it to you.
Alright.
So 2 point.
Did you wait? Oh, I'm sorry. Akil, did you use the full sample, the 3.9, or did you divide with the 2.9?
I did 2.9. What'd you do?
Okay. Yeah, I did 2.9 as well.
Okay, what did you get? Because I got, what did y'all get?
I got 0.018.
I got 0.0214.
That's what I got. The 214.
So I'm not great with mental math like that.
You're doing that in your head?
Mm-hmm.
Oh my
Oh,
goodness.
no.
Oh.
Okay, you guys. So for 4D, are we on 4D? Yeah. Okay. So for the number of moles, you're gonna do the 2.914 because it asks for anhydrous, and you're gonna divide that by the 136.144, and I got 0.0214 as my answer. Is everybody on the same page? Moles.
Yes. Well, yeah.
Did you say 0.214 or 0.217?
I got 0.0214.
Okay, cool. Thank you.
All right, so let's move on to 4.
0.0214.
Right.
Okay.
Okay, so for E, calculate the mole ratio of water to calcium sulfate. Round the answer to the nearest whole number. All right, so we should know how to do this, right? Because we basically calculated everything already.
Would it be like 0.
Oh yeah.
0 like 5 moles divided by 0.0214, or would it be different values?
That's right.
Yeah. So say that again so everybody can hear you.
0.055 moles divided by 0.0214 moles. And you should get 2.57. I don't know if that's right.
Hold on, I'm calculating it out.
Where
myself.
y'all get the
You get 2.57. Yeah.
Which
where y'all
number
get the
did y'all put together?
0.55?
And then it rounds up to 3 moles because that's for a whole number answer.
Actually, 2 point. It's gonna be 2 significant figures, right?
Can you repeat what you did again?
So for E, since you're calculating the mole ratio of H2O to calcium sulfate and rounding answer to the nearest whole number, and since we already calculated the moles, you're just dividing the moles of water to the moles of calcium. So you're gonna do 0.055 divided by 0.0214, and you get 2.57.
Thanks.
No problem.
Question, where did the 0.055 come from?
That came from your answer in 4C, which was the water.
Oh, okay, I forgot we have rounded it. That's why I got confused.
No problem. So you get your answer from 4C, and then you get your answer from 4D, and you divide them, and that should give you your answer for E. So what was everyone's final answer for E?
3.
Yeah, I got 3 moles for a whole number.
Yeah, because it says you have to round
Oh
to
yeah,
the
hold on, my bad.
Yeah.
Yeah.
Okay.
right?
Yeah, 3.
Right, so you should get 3. So if we got 3, what does that tell us for our formula? For 4F.
Then it's a 3-to-1 ratio, so it'd be like CaSO4 3H2O.
Right. Did
You said we
everybody?
got until midnight.
Wait,
I couldn't hear him.
Yeah, you glitched out.
somebody broke up. Like I can't hear.
Well, he said the answer was CaSO4 times 3H2O.
Correct.
Correct.
Correct. Because we found the 3 waters in E, right?
Hey, Morgan.
I'm listening.
Excuse me. Before lab is over, can you do one of the in the chart where it says MgSO4 times 7H2O, and it asks what's the product that results when the hydrates below are heated above the water, the boiling point of water. Can you do one of those?
Is everybody good with the math?
I'm lost at 4E.
For E? Hold on.
Yeah.
Okay, so we can start there. So calculate the mole ratio of, and while I'm speaking to Taylor, if you guys want to focus on the chart so that when we get to, we can go through it, that'd be fine. But I'm gonna go back to 4E so that everybody can be on the same page. All right, so calculate the mole ratio of water to calcium sulfate and round your answer to the nearest whole number. Okay, so in E, we already found the, so if we go back up to the top of our page, the mole ratio is the moles of your water over your moles of your anhydrous salt. So we already calculated the moles in question 4C for water, which gave us the 0.55, and we calculated the moles of the anhydrous salt in 4D, which gave us
The 0.02 and 4.
correct. And so you would divide those two and then you would round that to the nearest whole number. So you should have got something like 2.57.
Yeah. Oh, you said the nearest whole. You said the nearest what?
Whole number.
Yeah.
So you got 2.57.
Mhm.
So if you round that, you know, the 5 increases the 2 to a 3.
Oh wait. 25.7. Let me try again. Yeah, I got 25.7.
You got 25.7.
Yeah, I don't know why. Oh, wait. Yeah, I keep getting that.
You got it again.
Mhm.
Okay, let me calculate it. See what you're doing. Let's see.
Oh, I see what I'm doing. I see what I did.
Because it should be 0.055 and then 0.0214.
Now I fixed it.
Okay.
All right, thank you.
No problem.
Can you do 4F again?
Yeah, so, all right, so we found everything. So 4F is just a formula. So from 4E, we know that we have 3 waters now. So your formula would be CaSO4 times 3H2O.
I'm sorry, can you repeat that one more time, please?
Yeah, so CaSO4 times 3H2O.
Thank you.
Mm-hmm. All right, you guys. So for number 1, the hydrate, that's basically magnesium sulfate with 7 waters attached to it. So what would we call that? You remember that we look at our waters and we go by the prefixes, right? So what's the prefix for 7?
Heptahydrate.
Right, so it'd be magnesium sulfate, heptahydrate, right? Everybody following me?
Yeah, it makes
Yes.
sense. Yeah.
Okay, so somebody do the second one for me. What would that be?
Copper sulfate pentahydrate.
Right. The third one be iron sulfate. And what? Right.
Which number are we on?
We are number 1. So we're going back up to the chart on number 1 where it says write the correct names of the following hydrates.
Now, when the last one be trisodium phosphate hydrate?
Like duodecahydrate, I think.
Deca, is it Deca? Wait a minute.
I think Mark's right.
Fingers are so cold. Oh,
Which one?
Is everybody together? Everybody knows where we are?
Are we on the last one or
No, I know we're on one, but not really.
Yeah.
Okay, so let's start from the beginning. All right, so we're on number 1. You see where it says hydrate, and then under it says MgSO4 7H2O, right?
Yeah.
Okay, cool. So if we look at that one, it asks for the name of it. So from our studies in the other lab, we know that we look at the prefix of water. So the prefix in this case of 7 would give us what? What's the prefix for 7?
Hepta.
Right. So you know that MgSO4 is magnesium sulfate, right? So your name would be magnesium sulfate. And you finish the rest. What's the rest?
Heptahydrate.
Heptahydrate.
Okay, right. So does everybody have 1A? I'm just going to list that as 1A.
yes.
Okay, if we go to the second one, that is copper sulfate. Copper sulfate, and then what is 5?
Pentahydrate.
Pentahydrate.
And that's spelled penta, like Penta, right?
It is penta, yes, like
Because
pentagon.
my computer said it was wrong.
Really, it's like pentagon.
Yeah, I was like, yeah, thank you. You might be muted if you're talking.
I'm sorry, y'all. I got muted again. Okay, so did everybody get the second one with copper sulfate, pentahydrate?
Yes.
Okay, so the third one. Can somebody give me number 3? The third one.
Octahydrate.
Right, but what's FeSO4?
Iron sulfate.
So it's iron sulfate, octahydrate. What about the last one?
Sodium phosphate.
It has a 3 in front of sodium. So what would that be?
Wouldn't it be trisodium?
Right, trisodium phosphate. And what is 12?
Duodecahydrate.
Dodeca, right? Yes, from Kayla. Yes, that is right.
I don't know if you answered this, but somebody asked, is it not iron 2 sulfate? Because sulfate has a -2 charge.
Iron, hold on. Yes, it is. It's iron 2 sulfate.
Mm.
Mason, you're correct.
Okay.
Did everybody get that?
And in that case, the second one should be copper 2 sulfate as well.
Right. You have to add the charges. That's true. Okay, is everybody on the same page? Everybody's good?
On number one.
I just have a question.
I'm listening.
Okay, so how do you know that the charges is 2? Because I thought with the transition metals, we won't know what the charge is unless it's like said. Because iron can have a 3 charge, can it?
Let's look at the periodic table, right? So all right, wait. Wait. Yeah. Okay, so what was your question? I'm sorry.
I said that, how do you know that the charge is 2? Because I thought in the lesson about transition metals, it said we won't know what the charge is unless it's said, because they can have multiple charges.
Right, but you have sulfate connected to that, right?
Mm-hmm.
Right, so that would change if you cross them. Y'all know the cross method?
Yeah, okay.
Does that make sense? I don't know if
Yeah,
you know.
you forgot about that part.
I'm sorry, say that again.
I forgot about the crossing the charges, but
Yeah, that's how that one would work. Okay, so we have went over 1A and 4. So on you guys' own, can you do 2 and 3? And turn in by midnight.
Yes, ma'am.
Do y'all need me to do example of 2 so you know what or everybody can figure
Yes.
that out?
Yes,
can you do
please.
one
An
example?
example? Yeah.
Okay, let's see. It says write the products that result when each of the hydrates below are heated above the boiling point of water. See above, for example. So you have magnesium sulfate. It goes through. Oh, okay. Yeah, so you just write the magnesium sulfate. What is that? Okay, so magnesium sulfate 7 water, and it would have the heat sign, and you would break it down to magnesium sulfate plus. Okay, does everybody, okay, go to the top of your waters of hydration dry lab, and you guys see how it's written in the first example?
Yes, ma'am.
Let me see if I can show you guys. Hold on. Does everybody see how that's written? Or is it blurry?
It's blurry, but I can see it on my screen.
Right, so everybody see how that's written? That's how you write out those in that second box. That's all it's asking, to break it down.
So basically we just put a plus sign where they're multiplied at and then add grams behind H2O.
Well, tell me how you would do the first one so I make sure you're doing that right.
The first one I would put magnesium sulfate plus heptahydrate with the grams behind the H2O.
Right. That makes sense to
Alright.
everyone. Hello?
No.
That don't make sense.
All right, who's speaking? Who's speaking? So that I can.
I was Daniel.
All right, so for all right, so let's go over the table then. All right, so how would you write the products, Daniel, for magnesium sulfate with 7 waters?
The product NGSO4 times 7 H2O.
So when you break that apart, once it goes through being heated,
Yeah.
right? So then you would get, you just break it apart, right? Do you all see like the first example with barium chloride?
So are we saying only the salt will be left over, the MgSO4?
Yeah. I'm looking at barium and it has a plus sign at the for the product or the result, I mean the reactant or something. The result of it. So why does it go from multiplying to adding?
Because it's being broken apart. So barium chloride dihydrate is one whole complex. When you break it apart, you can just have barium chloride, which is your salt, and then you can just have water, because water is being removed from after being heated.
Well, once it passes 100 degrees, isn't the salt just going to be left, or isn't it going to
Right.
just?
If it passes 100 degrees, then you're just gonna have the salt, which is your, in that case, would be the BlCO2, the barium chloride.
I mean, for the two, wouldn't it all just be salt?